Thanks for joining us, guys, this Tuesday afternoon. You're in the ArcGIS Maps SDKs for Native Apps Overview and What's New session. My name is Rex Hansen, and I'm joined by Nick Furness. We're both product managers for the Native Maps SDKs. And we're going to take you on a tour over the next hour, kind of walking through, introducing our native SDKs and what's new over the last year. Before we get started, just want to mention that there's an app that we have available, an events app, and if you have the app and you'd like to give us some feedback, would love to get that. I just want to mention that up front. I'll mention it again at the end, just so you guys are aware that there's a mechanism there to give us some feedback on our presentation today. So let's start off with an agenda. We'll keep it simple. I want to do a brief introduction, kind of get our feet wet on the native maps SDKs and maybe why they're important. Let's talk a little bit about the architecture. We're going to run through the capabilities at a high level. Of course, we want all of you to go into production. And so we need to talk about deployment and licensing, right? It's not just development. So we'll talk a bit about that, and then what's new, and we'll talk a little bit about what we've introduced over the last year, and then we'll dive into questions at the end and take us into 5 o'clock. So first, introduction. So one key question here is we've got a number of Maps SDKs that are available. We've got SDKs for web, we've got SDKs for game engines, there's open SDKs out there, open standard-based SDKs. Why are native applications important? Well, to put it plainly, you can get the best performance and the best user experience by working as close to the metal with on-device applications as possible. So you can leverage device sensors, you can leverage device capabilities, you can leverage onboard GPUs and CPUs, you can leverage the frameworks that the devices deliver to enhance and enable better performance, better accessibility, working with local data, and enable access. As developers, you can work with all the full capabilities of the devices that you're targeting. Another benefit here too is that a lot of the developer tools that are available for targeting native platforms are advanced, professional, very capable, some of the most advanced tools and frameworks to be that are available to be successful in building out your applications. In addition, they're really they're designed for if you're working with mobile-based applications. You can deliver your applications through app stores effectively, so it's a nice, easy way to take functionality, build it for native capabilities, take advantage of on-device capabilities, and deliver that effectively through well-established application stores. Building on those capabilities, we've introduced the ArcGIS Maps SDKs for native apps, or in short, the Native Maps SDKs. These native maps SDKs are designed to introduce mapping and analytic capabilities, so geospatial analytic capabilities to native applications. One of the differentiators and benefits of working with our native maps SDKs is working offline, working with local data sources. Also, when working with devices, the location-enabled capabilities, a better blue dot experience, for example, those capabilities that are available on the device, whether you've got peripherals or that are built into the device, you can take advantage of those and work with that location with our mapping tools. Our native SDKs support multiple platforms, and so they offer the best on-device capabilities for desktop, mobile, tablet, and embedded devices, taking advantage of the resources that are available. We often say that it delivers the best mobile experience. And so if you're looking at developer products that we have within our ecosystem, if you're looking to build out an immersive mobile experience for example, iOS and Android devices, guaranteed you're going to get the best experience with our native SDKs. Best performance, best on-device capabilities, best local access to resources. Another part here too is, as with all of our Maps SDKs, it's designed to be integrated with the ArcGIS system. Really, all of our Maps SDKs act as a catalyst to be able to enable you to work more closely with the ArcGIS system and those capabilities that are delivered through the system. And when I talk about our system, I'm really talking about our foundational products. ArcGIS Enterprise, like a private cloud, ArcGIS Online, our public cloud, and Location Platform. Think of it as our platform as a service for hosted data, and then also ArcGIS Pro, our desktop GS Analyst product. We also have a wealth of data that we're also offering through Living Atlas. Our Maps SDKs are designed to catalyze your ability to access and take full advantage of those systems. Not only that, Esri builds apps. We build our own mobile applications that you can use and configure. You can configure to use for your industry, for your business out of the box. The applications listed on this slide all use our native maps SDKs, whether it's field maps, quick capture, survey 123, flight, navigator, earth, indoors. They use our native SDKs because they provide the best native experience, the best experience for our users, whether 2D or 3D. And oftentimes it hinges on working with on-device capabilities and local data. Let's talk a little bit about the architecture. How do we build this? Just to give you a little peek behind the curtain. So the architecture of our native maps SDKs, first, we're delivering 5 SDKs, and these are targeting 5 developer platforms that are standard developer platforms for native developers outside of Esri. We're building on top of them and providing mapping tools and analytics to those developer platforms. And that includes .NET, Flutter, Kotlin, Qt, and Swift. All of them are built on top of a vast majority of our operational logic is in a C++ core. We're building in C++ because we can operate close to the metal. We can take advantage of and we can implement everything at a very refined, performant approach to our implementation. It also provides consistency. And so when we start targeting multiple operating systems, Android, iOS, Linux, Mac, and Windows, we can build out a consistent experience that works similarly across multiple platforms, regardless of which SDK you choose or which developer environment you choose. Of course, behind the scenes, as part of our core implementation, we're providing implementations in our rendering pipelines like DirectX and OpenGLES and Metal. And of course, the different architectures that we can support. Whether it's 32-bit, 64-bit, we're working with Intel or ARM-based systems, Apple Silicon. We can take advantage of those on-device capabilities within our C++ core that's shared across all of our managed APIs. Now, what's interesting here is that these developer platforms, .NET, Flutter, Kotlin, Qt, and Swift, they can support different operating systems, right? And so if we take a look at the platforms that are supported by our SDKs, you can see a list here. So we've got some SDKs that are designed for cross-platform support. Like if you look at .NET, we'll support Android, iOS, partially on Mac OS through Mac Catalyst, but also Windows. And so you can use .NET MAUI to target multiple platforms and share much of your code. Or there's developer environments where we have a single target or a single vendor that we target. So for example, Kotlin for building Android applications or Swift for building applications that work with Apple platforms. Right, so more of an embrace the platform versus a cross-platform approach. Again, we want to make sure that you as developers have choices. Like, so you have knowledge in different areas, working with those developer tools, work with those developer languages. We want to be able to meet the developer where they are. And so if you're familiar with a language here and there's operating systems that you'd like to be able to support that are part of that developer framework, we want to be able to meet you there and provide you with the mapping and geospatial analytics tools that you need. Now, when you're building out these focused applications, when you might even be building an application where you're including mapping components. It's not the primary use, but it might be supplementary to what you're doing. Generally, you're working with developer environments. And so we've got a few that are common that are listed here. So for example, if you're working with .NET, generally you're building things in C# using Visual Studio. Flutter, you're building it in Dart is the language. Visual Studio Code is the primary IDE, and so on, right? So we've got a set of different IDEs that are used here as the primary developer environment, depending upon which language you choose. Now, what's interesting about this is it's not just an API, right? It's not just components. What goes into an SDK is more than just an API. So we provide comprehensive documentation so that you can be successful, so that you know what the API does. So we provide a comprehensive API reference. We provide conceptual guides, and so you know how to work with maps, scenes, 2D, 3D, offline, geospatial analytics, you name it, right? So at the end of the operations that we support, we want to provide you with concepts that introduce you to and show you how to work with our SDKs effectively. We provide tutorials, right, that basically walk you through the process, focused on using code. Again, I have to admit, as a developer, I love samples. Right? I like to look at samples because I want to see how did the people that designed the product intend for it to be used. Samples are a great way to do that, showcase some of the capabilities that are available. Our samples are available through our website. We have our samples available open source on GitHub. We also, in some cases where we can, we make the samples available through the representative app stores, right? Whether it's through Google Play Store, the Apple App Store, or Microsoft Store. So that you don't even need a developer environment. You can just download the app, you can take a look at it, right? You can start working with it. We also provide toolkits, and these are supplementary tools, components that allow you to use or take advantage of our native SDKs more effectively. So when you're building or working with a map or a scene, 2D and 3D, you might want to enhance those capabilities with a base map gallery for your end users to be able to choose a base map. You want to put a north arrow on the map for standard cartographic accuracy. Scale bars, working with feature forms for data editing. We even have things like authentication components that allow for you and enable to work with our extensive authentication workflows. Again, these toolkits are available on GitHub. They are part of the SDK, and so you can download, you can fork, you can provide feedback. It is obviously part of a developer ecosystem, and so it's important to be able to provide you with kind of a leg up or try to accelerate your developer experience. But you can also, as a developer, work with us in these platforms. So they are designed to be ready to use, and then you can customize as you'd like. I should also mention that as part of our SDK, we have Esri Community. Think of them as Esri forums, right? So we've got dedicated locations within the Esri community where you can ask questions and get responses, oftentimes directly from our development team. We also have tech support too, which is a formal approach to be able to get support on the product. With that in mind, I'm just going to do a brief run through of maybe a couple things that I really like about our site, our developer site. It continues to be updated on a regular basis, really refined in this approach. And I can't bounce over, so I'm going to actually, hopefully this is going to work. Okay, there we go. Good stuff. All right, we're showing it. Nice. Okay, so this is the developer site, developers.arcgis.com. This is the starting point. You don't have to log in. Everything's available for you to peruse and take advantage of and look at. So what I want to do here is I'm going to focus on the SDKs and APIs, because our developer site focuses on almost all developer capabilities within the Esri ecosystem. We're going to focus on the Maps SDKs. Right, so if we look at the Maps SDKs, we've got a nice list over here that includes web, native, game engine. I'm going to pop into .NET here, and this is just one example. Arguably, probably our most popular native SDK right now is the ArcGIS Maps SDK for .NET. We have a great place to get started here. There's a place where you can click in to go and get you started right away. Generally, this will focus on using location platform because you can create a free account. It's a pay-as-you-go plan. There's a generous free tier to get started working with our base maps and location services. It's a great way to get started. A couple things I'm going to highlight here other than just getting started is great tutorials to kind of walk you through the process. We have some sample code here too, which I'm going to click on here shortly. But I also wanted to highlight a couple things here too. System requirements. Oftentimes, you're building applications for systems. You need to know what's supported, not just your developer environment, but the operating systems that you're deploying to. System requirements is a great place to go to get a better handle on where that is. We keep all prior releases here too. Our product lifecycle is 4 years, and so when we release a product, generally it's going to be supported for 4 years. And so you're going to be able to download that product for 4 years and different levels of support, general availability, extended, and mature. We have an LTS release at the end of every major release, and that's a 5-year support cycle. So generally, we're going to have a series of products, a series of versions that are supported for a duration, and generally that's to allow for you to be able to support the appropriate operating systems and developer environments that you need to be able to support. But we are always pushing the envelope. We're always going to be releasing another product every 4 months. Be looking at like what's new in the latest environments, whether it's operating systems or developer frameworks. We're going to continue to push that. But the key there is we also need to have this responsible release cycle. And so what we'll see here is for any of the products that we continue to support, we'll see system requirements. You can go back and take a look at it. We'll also have a set of release notes. And so for right now, the current release is 200.8. We actually just released a patch for this, a proactive patch. And so we can go look at the release notes, see what was released, see what bugs were fixed, extensive capabilities here on what was added, what was deprecated, anything that was breaking. Great resource for you as you start to get started. So also prior releases here for anything that's supported, right? So great place to go. With that in mind, let's go back to overview. I just want to take a brief look here at sample code. So I mentioned samples, great place to get started. What's really nice here is that I can go into my sample code for whatever platforms are supported. In this case, we support Windows, iOS, and Android. The sample application itself is available through source code, but I can also download it from the Microsoft Store, right? So the Microsoft Store exposes this. I can download this. I can start working with it right away. I don't necessarily need a developer environment. This is what the app looks like. So I can click on something here and I can start seeing data right away. This is our 3D tiles layer, for example. Pipeline's a little limited, but we're bringing in a significant amount of 3D data here. And as it starts to load in, I can start working with it. I can actually view description. I'm going to zoom in here a little bit so I can see what it's supposed to do, but I can also look at the source code, right? So I can actually copy paste out of here, start working with it right away. If I want to, I can actually bounce out from that app, I could bounce out to the actual GitHub repo where the sample is located. So a great resource there for being able to work with and see how our SDKs function. In general, all of our native SDKs have this capability in some aspect. Some cases we can release it through stores, other cases we can't. But in every case, we have samples, right? And the source code for those samples are available. Great, so let's bounce back into the presentation. And we're good. All right, good stuff. Cool. So capabilities, let's do a high-level rundown on the capabilities. What should we expect our native maps SDKs to be able to accomplish? Well, just the basics. Let's start with 2D and 3D. We build out our SDKs in C++ so we can take advantage of the full breadth and depth of on-device capabilities, on-device resources, which means they're GPU powered with CPU fallback. So if you've got access to GPU on your device, we're going to take advantage of it. We're going to power that 2D or 3D experience or even analytical experience using the GPU. Maps and scenes that we're working with, think of 2D and 3D. They may be authored in Pro, they may be offered in the web. You might be working with mobile map packages, you might be working with web maps. In general, both of them are designed to be utilized effectively and consumed as created within our native SDKs. This is part of our WebGIS capability, integration within the ArcGIS system. Of course, then also data from services or files. So we can work in a connected workflow. We can work with a variety of services, whether ArcGIS or otherwise. We can also work with local data files as well, raster and vector, an extensive amount. And actually, Nick's going to talk a little bit more about our support for layer types going forward here in just a moment. Key capabilities, again, online and offline. So one of the key differentiators with our native SDKs is support for offline data, support with local data, local capabilities. And so that local data might be coming from ArcGIS Pro, right? One of our foundational products. I'm building out mobile map or mobile scene packages. I'm building out tile packages, scene layer packages. I'm working with that data. I could even be working with shapefiles in Pro, and I can use that in native SDKs too. Offline web map areas. This is a pre-scheduled or pre-planned approach where you're working with Portal, could be online or could be enterprise. You're building out maps, you're adding layers, and then you want to be able to pre-create or pre-cache those maps that then you can use within your application and be able to take those offline. And that is pre-planned in the sense that you know where you're going to be going offline in advance, so you can do that in advance beforehand. There's also being able to take services offline, and so in many cases, ArcGIS services support the ability to generate an export. Right, you can create a mobile geodatabase from, let's say, a feature service. You can create a tile package from a map tiled service. You can create a vector tile package from a vector tile service, right? So there's a dynamic aspect there as well. We support that too, right? Inevitably, you might be waiting for the service to be able to generate the file, but once it's available, you can download, work with it locally. Oh, there we go. We're going to skip past that. There we go. All right, location experience. So I mentioned before, it's important, especially when you're dealing with mobile applications of your location. Where are you located? How can I use that location in my mapping applications? Maybe something as simple as, where am I, what's around me, and how do I get there, right? So working with on-device sensors and capabilities that are plugged into your device, you might be working with like a peripheral Bluetooth device, a GNSS receiver, for example, to get high accuracy location. You might be working with a customized workflow, maybe beacon-oriented positioning workflow for indoors. You can work with a variety of different custom sources to get a better blue dot, to get a better location. As long as the device can get it, we can use it. Right? So you can plug into a variety of different components there, a variety of different networks, and as long as you have access to it on the device, we can work with it. Just to fill this out a little bit more, working with a full-featured mobile geodatabase. So mobile geodatabase is a vehicle for delivering basically Esri's geodatabase model in a SQLite-based format that allows for you to deliver, right now, vector data. So working with points, lines, and polygons. You can query, render, show, edit. It's also the foundation that we use for our sync-enabled feature services. We might call that a replica behind the scenes, but ultimately, the mobile geodatabase is key to be able to work with feature data as part of the ArcGIS system, especially in our sync-enabled feature service workflow, whether ArcGIS Online or Enterprise, or actually now, location platform. Geocoding and reverse geocoding, other operations that are just fundamental to GIS operations. So working with services or working with local locators, either way. Being able to work with and assign locations to text information and vice versa. Routing and navigation, another capability there that works online and offline. Not just being able to route to a location and be able to work with a navigation API to provide turn-by-turn directions, but also things like service area and closest facility may be considered more spatial analytical, but online and offline as well. We also have a geometry engine, geometry tools that allow for you to be able to work with common geometry operations like being able to reproject or simplify. This also includes things like interactive editing workflows. So being able to work with editing capabilities that enhance the, viability of editing capabilities, but also the validation that goes into it. And Nick's going to show us a little bit more about that here in a moment. Building on key capabilities as part of the ArcGIS system, WebGIS integration. And I mentioned this before, WebGIS is key, being able to create a map or a scene with layers, with analytics, with data, and then be able to distribute that across multiple clients. Really fundamental to our WebGIS capabilities. WebGIS is a key part of the native SDKs, as it is with all Maps SDKs. So working with portal APIs, working with web maps and web scenes is key to be able to provide or participate within the ArcGIS system. Of course, part of this too is security. You're working with private data. And so being able to work with different options for authentication, single sign-on with OAuth, working with our PKI capabilities or leveraging API keys going forward. There's a variety of different options that are oftentimes industry standards that we take advantage of and we build out support for. And this enables us to be tightly integrated with our foundational products, Online, Enterprise, Location Platform, and Pro. All right, just to kind of mop up some additional key capabilities here before we go into layer types. As far as additional technologies are concerned, dynamic entities. This is a unique type that's designed to be very responsive, but it's designed to support real-time scenarios, especially for things like situational awareness. It'll plug into things like stream services, which might be hosted by something called Velocity, or it might be working with custom feeds from a variety of different sources. Ultimately, it's designed to bring your real-world data, your real-time data to life within the APIs. Again, as part of that, we have something that we work with called geotriggers. Geotriggers is designed to work with really geospatially aware operations and determining their relationship to other geometry. And so that factors into a geofencing workflows. And so being able to take advantage of that on the client is an effective capability we have. From an industry perspective, working with utility networks for things like water, gas, electric, not just the ability to visualize and interrogate, but also the ability to edit, sync, and trace, so analytical operations that are available. If you're editing, you can regenerate topology on the client, and you can start working with it again operationally. All that's built within the native SDKs. Indoors capability here too, being able to work with our indoors product, our indoors solution, so that you can get a better location for your device inside. At the same time, being able to provide more awareness of where you are, so floor-aware maps and scenes are also important too, so being able to support indoor navigation and visualization workflows. And of course, I'll mention here just high-level extensive layer type support, vectors and rasters. We're working with ArcGIS-specific data types that are part of the platform, as well as open standards, a variety of formats. And I'm going to mention flexible license options here, because we're going to talk a little bit about licensing as you go from development into production. It's important to think about. But we have flexible options. So think about named users and license strings. Two different options for the same license model. And we'll dig into that here in a moment. But for now, I'm going to hand it off to Nick, and he's going to take us into a deeper dive on layer types. Nick?
Thanks, Rex. Yeah, excellent overview of the SDKs. And Rex just gave you a quick high-level overview of the types of layers that we support. I'm going to just jump into a few more specifics here. So feature layers, being able to pull feature data down from a service, automatically update the display, interrogate it, edit it. Raster layers, image tile layers, and vector tile layers, two different ways to bring more static data into your application. We'll see those as well. There's sort of pre-baked data that doesn't change quite so often. Wondering why I can't see anything. It's because I got too excited and took my glasses off. And then we get into scene layers, more specific 3D type standards like the i3S spec, 3D object layers, integrated mesh layers, point cloud layers. Those are layer types you can bring directly into your 3D scene view. And then map image layers, dynamic map image layers that update based off allowing the server to render the data for you and bring it down according to your current view extent. Then we get into some more specific types like annotation layers and dimension layers that may be a little more niche for specific use cases, like utility use cases. And then, as Rex mentioned, a dynamic entity layer, you can hook that up to a live service. If it's one of our live services, it can just automatically hook up. But there's APIs for being able to ingest data yourself and then automatically consume it in a live feed. Now, dynamic entity layers are a really powerful abstraction away from that raw data feed. So what you do is you set up essentially a way to identify what the current position of an item is. Maybe there's a key ID, and then in come a bunch of streams, and in come a bunch of updates. That turns into its latest feature position, but also a trail of historic observations. And our API abstracts all that away for you into a nicely usable, interrogatable collection of data, as well as, of course, as updating the map or scene on the fly with that data as it comes in. Then, as Rex mentioned, we've got OGC services, KML files, WMS, WMTS, the two vector types, WFS and API features, and then also added in the last year 3D tiles, OGC 3D tiles. And if those don't work for you, then we have a generic web tiled layer. Now, this is like the image tiled layer, but you can provide the image data to us as we ask for it. So as the user pans and zooms around the map, it'll ask your web tiled layer implementation for an image at a particular key, and you can just hand that back. Now, that could come from a network request. It could come from a local cache of some sort that you access. All you have to do is give us that image tile, and we'll display it for you. Those are all connected scenarios. As Rex mentioned, one of the key distinguishing features of the native SDKs is working offline. And so we have huge support for offline data as well. Now, you'll see feature layers, raster layers, available as offline sources too. So you work with those mobile geodatabases that Rex mentioned you could download or generate from Pro. Or there's even APIs to create mobile geodatabases in the SDK. You could work with a shapefile, or you could work with an OGC geopackage. There are various raster layer types that you can just put directly on your device and open, like geotiffs, JPEGs. As long as it's got Mr. Sid, as long as it's got the appropriate geo-referencing information with it, you will be able to open it and work with it. Now, it's a limited list, but I mentioned that information because JPEG inherently doesn't come with that. So you have to have auxiliary files that come with it that say, this is where this JPEG should be georeferenced. And we support mobile mosaic datasets. And again, geopackages, OGC geopackages can include raster information. We've got great support for KML layers. Those dimension and annotation specialty layers also work offline. And we support ENC layers when you're working offline. So your whole collection of ENC data sets that make up that nautical chart can be displayed in an offline app. As Rex mentioned, there are tile packages that you can download from a service as a TPK or TPKX. Vector tile layers as well can be exported as a VTPK. And then scene layers can be published from Pro as a scene layer package, which you can bring in. And even OGC 3D tiles can be opened as a local 3TZ file. And even dynamic entity layers. So with that customizable API, you could create a dynamic entity layer that doesn't go to a service. Maybe it feeds off something local. Perhaps you've got a peer-to-peer network and you're just feeding live information across that isolated peer-to-peer network, not connected to the internet in any way. You could bring those updates dynamically into your application. And as well, geospatial PDF, something we added recently, and we'll take a look at a demo of that when we get into the what's new stuff. But it's there. It may be new, but it's a layer type we support offline. So I'm going to jump into a demo now of some of these layer types, and we can see these in action. So this is just our sample app. And I'm going to start with adding an integrated mesh layer from a service. So there's a base map, but on top of it, we're pulling in an integrated mesh layer. You can see that crisp up as we get more and more of that high detailed I3S data in. So we start off getting the lower information and then bring in the higher and higher information. But this could work from a local file. So here's that same mesh from a local file, and you can see how much faster that works. Now, as I was preparing this at home, my internet at home is too good, so I couldn't actually discern between them. But here it's great. We're on Conference Network. It's a really great demo of how useful these local files can be. And of course, we can navigate around, explore, zoom in, see some of the detail here. I think Game of Thrones fans might recognize this. Anyway, benefit of local files versus service files. But we could bring in a local point cloud layer. So here we're looking at hundreds of millions of points rendered locally from a file on device. And this is San Diego. If you come to our conference there, you might recognize some of this in the conference center. But again, you can see the responsiveness. You can see how we can just quickly bring that in from a file. Of course, point cloud layers can also work from a service. Let's take a look at an OGC layer. Here's some of that weather that was making some of our flights so bumpy on the way in over the last couple of days. So this is a live WMS layer of current precipitation across the US. I'll switch over to vector tiles now. So one of the benefits of vector tiles is you can style them on the fly. One of the other benefits is that they render on the fly, obviously dynamically. Labels reorient themselves as you rotate the map around. But this is one tile service, our global tile service, that we can apply different styles to. So with the same tile service, I can just say I'd like to see it in dark gray canvas, or maybe I want this nighttime navigation style that we've created, or one of these more futuristic Nova styles. So again, one global tile service, multiple different styles. And you can customize these styles too using the vector tile style editor. Offline, key story here, here's an offline tile package, a VTPK of the area around DC. And again, we see that same detail and responsiveness. And again, we can have one tile package on the device and just apply different styles to it. So these are style resources downloaded from a vector tile style service, pulled onto the device, and we can just switch between them. You can also add a raster from a file. So you might imagine you're out in the field, you have a drone up, it captures an image, we can overlay that directly, it becomes a local file. Let's go back to OGC, and we're looking at a tiled service layer, a WMTS. So this is a service that is rendered remotely and pulled down to the service as we need it. KML, I keep forgetting this is an OGC type. It is. Here we've got a KML file with dynamically updating network data. So these are live flights in Europe, and it's actually 3D data. I can pull it down. All I had to do was add one KML layer with the reference to the KML file, and these flights are updating on the fly. We take care of those network link updates. A couple more layers to show quickly, just nautical charts here. So obviously we can display a nautical chart. We can change the styling of it. So maybe we want to change the depth that we highlight on this nautical chart. Or maybe we want to change the styling for a night view or a fully dark cabin view. So we have these capabilities within that same file just to apply different styles to it. The last layer type I want to show right now is our 3D base map layer. So this is, again, OSM data baked into 3D tiles, not 3D tiles, sorry, baked into our 3D base map layer, which we render on the device. But we can change the renderer. Maybe we want to see the edges of these things. So we can go in there and through the API change the renderer. We can apply a class breaks renderer. So buildings of different heights display differently. Again, straight from that single service. We can see what that looks like in London, for example, or pop back over to New York. I pushed my luck with the network here. But okay, you see the point. It's coming through. Yeah, so that's a quick summary. I just selected some of the layer types. This is one of those sample apps that Rex was talking about. This happens to be the Swift one. And I pulled all these examples out of there, with the exception of this one. I tweaked this a little bit. But you can grab our app. If you don't have the developer tools, just grab it out of the App Store and start playing with it. If you do have the developer tools, start tweaking it like I did here, and get to explore the different layer types we cover.
Yeah. What's also interesting there is if we go back to that table that I showed where we had the different SDKs and the different platforms that were supported, this is an iPad, right?
Right.
And so we have 4 of our 5 SDKs actually support targeting Apple platforms, right? So we could use, if we're a .NET developer, we could work with .NET MAUI actually to target the iPad. We could work with Swift, with our Swift SDK. We could use the Flutter SDK to target iOS. We could also use Qt, right, do that as well.
Great.
So we have 4 of those SDKs that'll target the same platform. What's interesting is that because we're building around a common core, the same capabilities are available regardless of which managed API you choose, right? So it's not like you get something better from our SDK if you work with one versus the other, right? As far as the functionality is concerned with respect to our native SDK, it's the same, right? So we just try and meet developers where they are, depending upon which language they want to be able to speak or program in, right? So
Exactly.
we flip
so with
over.
that, I'll hand it back to you.
All right, great. So now the fun times. We get to talk a little bit about business actually here too. Before we dive into that though, I want to do like a quick poll. We're a little over halfway through. Anyone here plan to develop or is already developing in .NET? Okay, so almost everybody. That's interesting. No, I'm just kidding. Anyone Swift? Anyone developing in Swift? Okay, there we go. Good stuff. Multitasking. There we go. Good stuff. Kotlin? Okay. Nice, nice. Flutter? Ooh, okay, okay. Good stuff. And then Qt? Nice, good stuff. Nice. Okay, Qt. Good deal. Good deal. Anyone targeting Linux on Qt? No? Okay, good stuff. Anyone building with Java? Ooh, okay. All right, some holdouts. Good stuff. Very good. Good deal. Good deal. Hey, thanks, guys. Just trying to get a good handle on what you guys are working with. I'm actually curious, anybody interested in working with React Native out there? We do have a couple. Okay, good stuff. That's good to know. Good to know for future reference. Thank you. Okay, great. So let's talk a little bit about deployment and licensing. So now to gain access to our developer tools, to our native SDKs, you don't even need to log in, right? So there's a variety of different package management systems that deliver our developer tools for you to start developing with. In developer mode, which means no license has been set. If no license has been set, which is what you get with our native SDKs, right when you download and start working with them within your IDE of choice, everything's unlocked, right? So you have access to everything, all the different data sources, operational capabilities, but you will see a watermark in your map of your scene. It'll say for developer use only, right? So you know that you're working in developer mode. If you want to transition into production mode, you need to license your application. Now, it doesn't happen implicitly. There's no magic behind the scenes. As a developer, you have to write code to license production use of your native SDKs. In every SDK, there's a set license call. And that set license call, when that's called, if it works, you're going to go into production mode, right? And when you go into production mode, the API locks down or is limited based upon the level and extensions that you've enabled, right? So developer mode, by default, you go download, you haven't even logged in to anything yet at that point, you're just working with it. Everything will work, right? You'll get the watermark. Go into production mode, you've called set license, now you're gonna get locked down, right, at some point, based upon the level or extensions that you have available. So the key part there is that when you go into production mode, of course, there's the technical aspect of that, where you're actually building out the components, you're delivering that with your application, you're putting it in the store, for example, you're distributing it for install. But there's also the business side. So you need to evaluate what capabilities you're taking advantage of or using within your SDK to go into production mode. What license level, so every deployment, every time you go into production, you have to be licensed at a level. We'll talk about that in the next slide. And there's some optional extensions depending upon what capabilities you need. There's 2 different options for licensing. One is the named user approach, which means an ArcGIS identity. If the users of your application in production have an ArcGIS identity, it's an option. If they can be online at least every 30 days, fantastic. You can take advantage of basically native SDK licensing built into named users, built into your user types. If you don't have users, right, or if you can't guarantee they're going to be online every 30 days, at least every 30 days, then we also have the license string approach. The license string approach is basically a string that licenses levels and extensions within your code. In either case, you're still calling set license. It's just in one case, you're passing basically portal info from an authentication workflow. In another one, you're actually passing a string, right? And so the license with ArcGIS Identity, the license travels with the user. That one user can unlock any native SDK that's been built to support it. With the license string, it's associated with the app, right? So it's per deployment. That's generally per app, per device, available to a single user. So you have to track that, right? So what are those levels? Like, what are we talking about here with respect to levels? So the first level is light. So our light license level, which is synonymous with the viewer user type, which you get with the viewer, you have the option of choosing to use it. Basically, you get most of the functionality that's in our native SDKs. Again, this is a catalyst as an entry point to our ArcGIS system, right? So it's a catalyst to enable people to use our foundational products to the greatest extent. So we want people, we want folks to get started, work with the ArcGIS system. And so that's some of the capabilities that you get with the light license level. There's no cost, unlimited deployments at light, right? So if you decide to go with a license string, you don't have to track it. At this stage, you can deploy as many times as you'd like. But what it enables is the ability to work with maps and scenes that are part of the ArcGIS system. You create a mobile map or mobile scene package. It's using data that's part of the system, covered at light. You're working with routing and geocoding, local or either online or offline, it's covered at light, right? So a lot of functionality is available at light. But if you transition into the next level, which in this case, you're looking at the first paid tier, basic, synonymous with contributor and mobile worker user types. This is where you might land if you start editing features, right? Especially if you're editing private data. That means data that's behind a network or requires authentication, requires a basic license. If you want to use our navigation API, turn-by-turn directions, requires a basic license, right? So two key pieces there at basic. Next level up there is standard. So standard, synonymous with the creator user type. Generally, this is where you see access to local data sources, additional local data sources, non-proprietary data sources, things like geotiffs or shapefiles, things that Esri doesn't own that you can create and manipulate in other products, but you want to be able to access locally. This also includes things like 3D visual analysis, and as we start to add additional analysis tools, anybody see spatial analysis this morning on the plenary stage? Actually, towards the end. As you start to see some of those analysis tools show up, they're probably going to be at standard, right? So because you're working generally with local data, you can create local data from those results, pretty extensive capabilities. I also mentioned local server here. Local server, anyone here thinking about or has touched or even knows what local server is? Any familiarity with local server? Okay, a few. Okay, good stuff. So local server's been retired. Local server's been deprecated. Ooh, I should rephrase that. Okay. Local server's been deprecated. It gets retired in 2030. So there's a little asterisk here to indicate that it's deprecated. The key is with local server is that it's designed for Windows and Linux systems only to be able to enable ArcGIS engine developers, much older, like developer technology, to transition to our native SDKs more effectively. And so generally what it offers is access to larger numbers of local data sources like rasters or file and enterprise geodatabases, and also geoprocessing tools. We're in the process of implementing that work within our native SDKs, so it's not just supported on Windows and Linux, it's also supported on other platforms like iOS and Android, right? So we're filling the gap with respect to local servers, so we're gonna fill that gap over time. Obviously looking for feedback from you guys as to what's most important, because we wanna be able to prioritize what you need. We have an advanced license level here too, Professional Plus. Right now, it's really dependent on what's available in local server, but we'll see that expand in the future. But those are the 4 license levels that we're focused on. There's also a set of extensions that are optional. The first extension, Advanced Editing, allows you to edit utility networks online or offline, but then once you edit it, it also allows you to, or enables you to validate the topology as well. There's some minimum levels here required in order to enable that extension. Analysis, some specific analysis capabilities like service area, closest facility. This is where some of the geoprocessing capabilities we see in local server light up. And then StreetMap Premium, which is basically access to StreetMap Premium data packages for different regions, right? And it allows you to view, geocode, and route based on those packages, pre-created data, basically. Great, so a nice little run through on the business side. Just to give you kind of a heads up, we have some pretty extensive doc actually that walks through all of these as well. So I'd encourage you to go take a look at that to kind of walk through the process if you're looking at going into production, you want to know where you want to license your application. But now let's talk a little bit about what's new. So what's new, release status. I mentioned this before, our latest release is 200.8. Our 200.8 release is our last minor version release for the 200 generation, so it's an LTS release. LTS means 5 years of support, 2 years of general, which means patches and hotfixes and maybe operating systems we'll evaluate. 1 year of extended, which means we'll consider patches and hotfixes, and 2 years of mature, which means we'll just support it at that point. But it's 5 years. We've had with our LTS release, we have proactive patches, so we'll have 6 patches. That's the plan right now. This is of course subject to change, but right now the plan is to have 6 patches. So at about every 4-month cycle, we'll be looking at having like another patch for our LTS release, taking us all the way up to 200.8.6. Hopefully, at the same time, you'll start working with our next major release, which is due next month. And to learn more about that, come to our Road Ahead session on Thursday. So good stuff. All right, so let's take a look at what's new. So what have we introduced over the last year? Primarily in 200.7 and 200.8. So geometry editor, we've done a lot of work around feature editing, and we want to be able to optimize that workflow. So we've enhanced this reticle tool, optimized for touch-enabled workflows. We've provided programmatic access. We are a developer product after all, so we want to be able to give developers more control over what's happening. And so we can attach actions to buttons. We can improve the interaction with Sketch. We can identify elements that are within our Sketch editor. And it gives us the ability to discover and set precision and tolerance. So some great work there. I think, Nick, you're going to be showing a little bit of that here shortly, the editor experience, and editor enhancements going forward. Utility network, we continue to target and support utility network workflows going forward. This was just enhancing the validation and the precision with respect to being able to edit geometry associated with utility networks. So leveraging snapping capabilities, working with associations, being able to visualize those associations effectively in attribute displays like forms and pop-ups. What's new on the real-time side? Dynamic entities, I mentioned these before. These are really features that are designed to respond to other objects around them and proximity to those objects. And so working with different spatial and attribute capabilities within those entities. So it's designed to work for real-time data workflows. And then this last one here is working with geospatial PDF. This was a new data type that we added support for middle of last year. We actually saw this on stage this morning. We talked a little bit about how geospatial PDFs have been critical in the emergency response space, especially in fire protection. And being able to display that in a 2D map was enabled recently so that we can work with the geospatial information in a PDF effectively. And then other things that are what's new here too, we support OGC 3D tiles. That was part of our larger system-wide effort for supporting 3D tiles in the ArcGIS system as a whole. That came into effect a little under a year ago. 3D base maps, working with 3D base maps and the buildings layer that's available, the Esri buildings layer in our 3D capabilities. So in further enhancing our 3D functionality, coordinate grids was critical for defense, certainly defense workflows. Being able to enhance or change renders, we saw this in the sample that Nick just showed, where we can change renders on the fly. And of course, enhancing our support for an OGC format like KML with multiple tracks, being able to show those as well. There's a lot more that we've added in here too. Image overlays and 2D maps, that was something that we had in 3D for a while. We finally got it in 2D. Support for identity-aware proxies, you work with Entra, and you want to work in an integrated fashion, be able to add that support, something that we enhanced. And we actually continue to enhance that going forward. Annotation and dimension for a better experience there for working with ahead of time or pre-planned workflows. Subtype group tables, again, working with capabilities that underlie a lot of our support for utilities is key. Indoor positioning has been important here for enhancing accuracy and positioning, working with different filters that allow for you to accommodate the sort of the realistic behavior of users in the field. And then some performance improvements. We're always iterating on performance, making our data layers perform faster, better, more effective, taking advantage of on-device resources. With that in mind, I'm going to pass it back to Nick, and he's going to take us through the ArcGIS Maps SDK for Flutter to kind of close us out and talk about our newest SDK in the family.
Yeah, so you've heard us talk about the ArcGIS Maps SDK for Flutter for a few times. In the session earlier today, we talked about it in the strategies around cross-platform mobile development. Rex mentioned it as one of our 5 SDKs. It is a full member of the family. We decided, in order to get it to market quickly, that we would do something unusual for us. We released it as a subset of the SDK capabilities. So we had a very popular beta program where we solicited feedback from participants and identified an MVP set of capabilities and decided to release those as full quality. So you can rely on those capabilities as you would if you were using them from any of the other SDKs. And over time, we make a commitment to building out the Flutter SDK until it reaches full parity with those other SDKs. But whatever we release is going to be full production quality that you can work with. So let's take a look at some of the things that we've already got in there. So we kicked off with a strong set of MVP capabilities, and we added things over time, like raster APIs. Additional location APIs for working with external devices like NEMA devices, geotriggers, the navigation API. 3D was a huge one. Suddenly just showed up, and that's testament to the C++ core that we've got built. We can release this essentially mature capability in a new API. Pop-ups, authentication, started to work on an open source toolkit. Initially, we focused a lot of work on the parity of the SDK and the API itself. And now we're starting to work on bringing some of those toolkit components in. Yet to come are some of these things like utility network, dynamic entities, and so on. So I'm going to let's see what happens if I switch over here. Nothing. Okay, I'm going to jump out of my presentation and then switch over. And now we're looking at our public parity page. So you go to the Flutter SDK homepage, there's a prominent link at the top that takes you straight to this page. This is our commitment for what we're going to release. And you can see what we've released recently highlighted at the top, 3D pop-ups, authentication. We keep a running tally of all the things that are released so far, but the key bit is down towards the bottom here, where we talk about how we're going to deliver parity across those other features that are not yet there. We've broken it down into what's coming in the next release. That's something we're really confident about, and then things that are coming soon. So you'll see at the 300, we're going to get utility networks added. We're going to get some APIs that people have been asking for around feature reduction. We'll read a web map or a mobile map package with feature reduction configured in it and display it, but you as a developer don't have the APIs to tweak that on the fly. Well, you will at 300. There's some labeling APIs that we need to add. And actually, little sneak peek into the future, dynamic entities will make it into 300 as well. So with that, let's just take a quick look at some more demos of some of the new layer types from the last year. We're back into the same sample app, only this time running on my Mac. It's the same app running under Mac Catalyst. And here we're looking at 3D tiles. Now, Rex gave you a little sneak peek at this earlier when he was showing the app running elsewhere. So this is just a sample data set. You can see, if I can figure out how to navigate on a Mac with a trackpad, this is a limited extent 3D tiles layer, but it's being pulled in from a service. And as you zoom in, you can see the data crisp up exactly as you'd expect it to, right? Coming in over the wire. But again, that OGC format. The other thing I want to show that we added in this last year is geospatial PDFs. These are key for a lot of quick turnaround emergency response scenarios. And we can turn these on and off just like any other layer, right? Focus in on a particular fire boundary, turn layers on, off, add them just like they actually end up being a raster layer. A specific type of raster layer pointing at a local PDF file. One last thing I want to show really quickly, if we switch back to my iPad, which I think is number 4, or maybe number 3. Here we go. So here, I just want to show some of the enhancements we've made to editing. So I'm looking at a utility network data set here. I'm going to add a residential service line, and I'm going to turn on the reticle for this. So we can see that this is snapping to all sorts of things right now. My finger's out of the way, so this is the power of the reticle, is I can use this in the field with gloves with my fingers completely out of the way, but it's snapping to all sorts of things it really shouldn't. I'm going to go ahead and turn on utility network-driven snapping rules. And we can see we can look at the utility network, understand what we can and can't snap to, and then just apply that directly to the rules. So now you'll see I'm not snapping to this main anymore, but I can still snap to this. I'm allowed to snap to this. And I can go ahead and place that utility line according to the rules that are defined in the utility network itself. And that's just set up with a couple of lines of code on the utility network. So with that, I'll jump back into the slides, I think, and hand back to Rex. Let's see, where were we with the demo? Yeah, and I'll hand back to you on your 5, I think. There we go.
AV guy? We're going to do this. I was going to go mobile on that one, but this is the last slide. So thanks for joining us for this intro session. I want to leave with one last slide at the end here, which is what's next at the Dev Summit 2026. So we've sectioned off our sessions here into SDK sessions for very specific developer tools and platforms, capability sessions that talk about really cross SDK capabilities that might be focusing things on working better with maps or location or working with utility networks or featured editing workflows. And we of course have the Road Ahead session, which is on Thursday evening, sort of the session right before the party. So, bring what you'd like. It's kind of a carnival atmosphere. It's good stuff. So we like to kind of take it into Thursday night in a good way with some positive, some positive news, right? So we should have some great demos this time. There's the location there, 5:30 p.m. Thursday on Catalina. Catalina's right around the corner here. A good place to be. I also wanted to highlight the fact that we've got a keynote on Thursday morning. And we have a couple of customers that are using our native SDKs to be successful in this space. We've got Salesforce and Norwegian Air Ambulance will be on site and talking about the successful work that they've done with the Maps SDK for Kotlin and Swift and for Flutter. And so we're really pleased to be able to welcome them to the stage, talk about the success that they've had in that space. It should be really exciting to see some of the work that they've done there. And so I just want to call that out too. This is a QR code that goes to a blog post that we put together that gives you kind of a rundown, right? So you can see all of these sessions and where they are and how to get there. Feel free to use that if it's helpful. And with that, please share feedback. I know we went a little bit long. Sorry about that. Content rich, which is nice. And then we can dive into, of course, feel free to connect with us on social, and then feel free to come up if you have any questions afterwards. But thanks again for joining us. I'm looking forward to talking with you guys further. Thanks, guys. Thank you.